Hello, good morning, everybody. This is Thursday the 20th of October, and it's Things on Thursdays, the weekly live stream where I look at some Redis topics with some IoT devices, and we're in the middle of building something with I think this is week 4 of building a project with the Raspberry Pi Pico W and Redis streams. So I'm going to do a little bit of a recap. So I was actually off last week. I was traveling. I went to a conference and presented a Redis Streams workshop. So it was great to see some people there that were also doing IoT type work. So that was fun. Got out and about for the first time in quite some time. Also, you may have some slight background noise here. It's actually raining quite hard on the roof of the building here today. So we'll see how that goes for us, but we'll soldier on anyway. So what I was going to do today was just start with a recap of where we are and then move forward with a couple of tidying up tasks that needed doing. And we've been gathering data from a sensor or a couple of sensors on a Raspberry Pi, and we've been storing it in Redis JSON documents, and we'll look at that. And then I wanted to do today was also index those documents so we can do some searches on them. And then in the next episode of this series, which will probably be the final one for this project, so we'll move on to a new project after that, I want to look at displaying some of that data on a second Raspberry Pi device. So we'll see how that goes. So let me just get organized here and share my desktop. Okay, here we go. So we have been working with this kit here, which is a Raspberry Pi Pico kit, and it has a load of Grove sensors, which is the standard for plugging sensors in. So what you can see here is you have to solder some headers or some pins on the Raspberry Pi Pico. You put it in this Grove shield, which is a way of connecting these sensors using a standard connector. And then from there on, there's no further soldering. You can sort of prototype your project out simply by plugging sensors in and writing, in our case, MicroPython code for them. So I've been doing that, and what we've been doing is we've got a Pi Pico that I'll hold up to the camera here with a couple of sensors on it. It's got a light sensor, which should be interesting today because it's quite dim, and it's also got a temperature humidity sensor. So we're getting 3 values out of this thing, and we've written some Python for it that puts those in a Redis stream every few seconds. So the code that we have is in this repo here, which I'll put that in the comments in case anyone wants to follow along. And let me put that in the comments here. Okay. So this is a repo that we're using. I've actually done a little bit of work off stream between streams. And what I've done is added some more sample data. So we've got some more rooms in our building that we're recording these temperature, humidity, light values for. And I've gone ahead and figured out how we want to index and search those. So we'll look at that in a bit. But before we do that, what I was going to do was take a look at the data where we left it in Redis. So I have got Redis Insight up and running here. And this is connected to my Redis database. This is in the cloud, so you can get a free Redis cloud database. Just go to redis.com/try-free, and you'll be able to get a free 30 meg instance there. That's what I'm using. It comes with all of the features that we're using today. So it comes with search and JSON plus some other stuff. So yeah, sign up for one of those if you need it. Obviously, you can also run Redis on Docker or install it locally. The great thing with the cloud is it's on a server, so my little sensor can reach it from wherever on my Wi-Fi. I don't need to start messing with opening ports on my laptop or things like that. So what we've got is 3 keys going on here at the minute. We've got a stream, so a Redis stream is a sort of append-only log or buffer type structure of data. That is storing temperature, humidity, and light values that it's getting from the sensor. And each one of those gets a timestamp ID. So they're stored in a time, it's sort of stored like a time series, really. Each ID is a timestamp, and then dash a a sequence number in case things happen so fast that Redis ingests more than one reading in the same millisecond. Unlikely in this case because we've got one sensor and it's only sending readings every couple of seconds, which is a lot faster than it would in a real world environment. And what happens is this data comes in and it just builds up in the stream. And then we built a consumer that reads it. And we've built some other logic that puts it into some JSON documents. So each sensor here, so sensor has an ID. We've got sensor 1. It's in a room. So we've got a Redis sorted set that maps sensors to rooms. So the room number here is 214. That's the score in the sorted set. The member, the unique value we're storing is the sensor ID because there can only be one of those. That's sensor 1. So we can have a sensor can only live in one room because sensor only has one ID. It's a physical thing. But a room, so here 214, for example, can contain many sensors. So a sorted set's quite a good way of looking at those sorts of one-to-many relationships. It's not necessarily what you first think of using it for. It's often used for a high score table or something like that. And we covered this in a previous stream. So if you want to see how we built that and the logic for how it works, then go check out the previous episodes of this series. And then our third thing here that we've got in the database at the moment is we've got a JSON key. And that's a JSON document that contains some data about a room. So here I've chosen the key scheme Pico project. I'm using Pico project for all of my keys to namespace them nicely. And then room, because it's a room, and then the room number. And then in here, I've got a JSON document that has the room number, some pretty arbitrary data that I decided to store about it. So how many windows has it got, a text description. Then we have this nested object in here called climate. And inside climate, we have temperature, humidity, and light. And those are values that are coming from the sensor indirectly. So they're coming from the sensor into the stream. The sensor doesn't know anything about this JSON document. It just puts things in the stream. And what happens is we've then got a consumer that reads the stream and works on it. And today we're going to work a bit on the consumer. But first, what I want to do is go back to the stream here and turn on this really handy feature for auto refresh. Then what I'm going to do is I have the Pi Pico here with the sensors on it. I'm just going to apply power to it and it will boot up and connect to the Wi-Fi. And let's get this the right way around. There we go. It will, nothing much to see here, but it will boot up and connect to the Wi-Fi and we'll start getting some extra data in here. So what we can hopefully see is something newer than the 19th of October. So yesterday, the last time. Here we go, 20th of October. We're already getting readings. And I'll see if I can make that a tiny bit bigger for you. There we go. So 20th of October, we're getting readings from sensor 1. It's apparently 25.7 Celsius here in my office, 54% humidity, and 146 and change on the light meter. So if I actually cover the light meter up with my hand, hopefully we'll see, there we go, those numbers have diminished greatly. So down to 512, 256, and let go, and back it comes. So we have data coming into this stream, and I will just remove power from the Pico now, so we're not spending the entire time we're on live stream here filling up Redis with stream data. So we've got data coming into the stream. It's stopped now, so I can turn off my auto refresh. And we need to do something with it. So we need to take values out of here and update this document. And how we've been doing that is with some Node.js code. So if I switch over to VS Code here, I have that project checked out. And we have, I'll just quickly review the MicroPython code in here. This is running on the Pi Pico. No operating system there. So we have to manage things like connecting to Wi-Fi. And again, let's just make it a little bit bigger. And we have to connect to the humidity temperature sensor. We use an example code that Seed provided for their sensors here. And then we're using a very simple client for Redis that's available for MicroPython. And we are reading values into temperature and humidity and light from the sensors. And then we're using the xadd command in Redis just to push that into the stream. And that's basically all the sensor knows about this. The sensor doesn't timestamp it. Redis does when it receives it. So the sensor doesn't need a real-time clock. And it basically then just prints these out if we happen to be watching on the Python console, sleeps for a couple of seconds, does the whole thing over again. So that is our producer here. It is running on the hardware. We could run it on many bits of hardware and give each one a unique ID. We have a secrets file that hides the Redis host port password and some other stuff like my Wi-Fi credentials, but nothing fantastically interesting there. So that's our producer. It's in MicroPython. That's a good choice for the Pi Pico. It runs that or pretty much a C-like environment. So MicroPython is quite approachable. And in the first video from this series, we looked at how to install that on there and what you can do with it a little bit. So over in the consumer land, so what's pulling things off of that stream or what's reading that stream, it's kind of important to remember that when we read a stream, we don't change the state of it. So reading things doesn't remove entries from it. And that's something that we're going to address a little bit today. So here in my stream consumer, I'm writing this in Node, which is a pretty arbitrary choice. We could have written this in Python as well, but I chose Node so that we have a code base that appeals to more people. Also, maybe you learn something different from looking at this. This could have been any language that has a Redis client. So it could have been Golang, or it could have been Ruby or Java or C# or anything you like. We have something a little bit similar. So we have some secrets. If you're watching since the last stream, I've moved them into a .m file now, so I don't have to keep setting the environment variables every time. We create a Redis client. So we're using Node Redis for this. And then we connect to Redis. And then what we do is the way that the consumer works is it reads from the last ID in a stream that it's seen. It asks Redis, give me something that's bigger than that. And then it works from there. So what we did in a previous stream was we added a memo functionality. So that information gets remembered in a key in Redis. So we store Pico project consumer last ID will contain the last ID in a stream that this consumer read. And if it's not there, we sort of belt and braces this and start with the lowest ID, so 0, 0. So we're going to start from reading the end, the earliest thing in the stream. And then this is also going to sit in a while loop. It's going to sit in a while true loop. We're going to use the xread command, which is something that reads from a stream. So again, reading doesn't modify it. And we are going to give it the stream name, and we can read from multiple streams at the same time. We're just providing one here, which is why we have this array of objects. And we're going to give it the ID of the last message we saw, which is going to be 0, 0 to start with. So basically the oldest message in the stream. And then after that, we're going to remember that and feed it back into this in the next call and say, give me the next one and the next one. And down here, we're just saying I want one message at a time, which seems a sensible number of messages to process. And if there are no messages whose ID are bigger than the one that I'm providing, I want to hang around for 5 seconds. So block this command for 5 seconds in case something turns up. And we look at what comes back. We either get a response or we don't. If we get a response, we have to unpack it a bit to get the data out of that. And we unpack things like the sensor ID and the message body, which is all the name value pairs in the stream body. And then what we have to do from that ID is dereference which room it's in. So for that, we use the sorted set. So we're using the Z score, Z score if you're English, last letter of the alphabet score if you want a neutral way of saying it. We use that command to say, okay, so for this sensor ID, which is the member in the sorted set, what is the score? And the score is going to be the room ID because that's going to give us the room key that we need to make up this JSON document. So we say sensor 1 is in room 214, and then we're going to update a JSON document with the latest values, which is what we do here. So we update that climate object. So here we're using a JSON path $.climate, and we're updating the values that go in here. So if I then run this a bit, what we should see, if I turn on the refresh on here, is that as it processes these entries in the stream, The data in here is going to change a little bit. So the climate data is going to change. It might pop close every time we do it. So let's see. So I'm going to go into the node folder here and do node index.js. So off it goes. It's processing messages, and it should be updating these values in here. So 24.9, if we refresh, 25.1, yeah. So it's basically updating this every time it goes through. So that looks good at the minute. So we've got something that's reading the stream. It's updating this. So we've got a sort of document in Redis that's describing what the current state of this room is. So, you know, how many windows it's got, what its description is. I'll turn this refresh off, and so on. And now we got a couple of things going on here that we need to address. So first up is if we look at the climate values in here, they're all strings at the minute. So this is a bit of a problem because when we're going to use search later, we're going to put a search index over this. I want to be able to do range type searches. I want to find temperature between this and that. I don't want to do temperature equals 25.1 as a string. I want to do temperature between 20 and 26 or something like that. And we've got the same problem for humidity and light. And the reason for this is that everything in the stream is just name value pairs. So Redis clients don't necessarily give them a data type because they can't infer one because it's just a name value table. So they all get to become strings. So what we need to do is sort that out. And the other thing we need to do is, if you look at this stream here, I have 351 entries in it. I had 351 entries in it before we ran the consumer. So reading it isn't dealing with removing entries that we've either dealt with or are just too old now and we don't care about them. So there's a couple of ways that we can trim a stream in Redis. So one of them is by providing a length that we want the stream to be. So we could say, I want the stream to be capped off to like 100 entries, and it will delete the oldest ones up to there. We can say we want that exact or approximate, and approximate is a little bit more efficient because of the way the tree structure that this stream is actually implemented as works. Or what we can do, which is what we're going to do today, is say I want to trim a stream so that an ID of an entry in the stream that I provide becomes the minimum ID. So basically anything older than that ID goes away. And that's what we're going to use to manage our stream, because if we don't manage it, eventually we'll run out of memory because we're just putting things into memory. Yeah, it's pretty efficient. At 351 entries, we're using 13K because Streams is also intelligent about how it stores things. And if lots of stream entries have the same name value pairs, it will cope with that and compact them. But, you know, eventually we're going to run out of memory one way or another, and we don't want a runaway data structure. So where can we trim a stream? If we go to the browser here and take a look at Redis.io commands, these are filtered by group, so we can pick the stream group here. And there's a couple of places we can trim a stream. So when we're adding something to the stream, we've got the option to trim it. So we can provide a trimming strategy here and say what our threshold is. We can say, I want, trim it to 100 or trim it so the minimum ID is this given ID. And it will do it when it adds it. The benefit to that is we don't need to add an extra sort of component into the system. So we could do that. I'm not going to do that today because our producer is this tiny little Raspberry Pi Pico, and we don't want it to be doing any more work or having more intelligence about how the system works than is strictly necessary. So it essentially should just be a broadcaster, right? It should just do xadd, 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 put the thing on the stream, do the minimum work possible. It also doesn't have a real-time clock. So if we're basing, if we want to remove things within the last hour, we would have to get some sort of network clock set up on it and figure all of that out. Or we'd have to start using timestamp entries that we get back from xadd which returns the timestamp of what it added, and then calculate an hour, and then the next time we do an XAdd, provide that entry as our minimum ID. So that's all work that we need to do on this very small device. So we're not going to do that. The other place that we can do it is basically anywhere we like in the system or anywhere in the architecture using this xtrim command. So xtrim here will do the same thing. It trims the length of the stream to either a length or an approximate length if we want to use that method, or a minimum ID. So entries whose ID are lower than the one provided. So we're going to use minimum ID. We're going to use xtrim, and we're going to have a component that we would just run periodically and say, okay, blow away anything that's older than an hour, in this case, in the stream. So yeah, if we've got temperature, humidity settings that are older than an hour and we haven't processed them yet for some reason, we're going to say they're not really that interesting anyway, and we'll delete them. So what we're going to do is write a new component that does that. So I'm going to do that in the node folder here, and we'll create a new file, and we'll just call it trim.js. And one day I will remember to set my editor to use 2 spaces, because that's what I prefer to do. So this is just going to connect to Redis, and it's going to run the xtrim command. So we need some code that we can kind of steal from here. So we're going to take, let's take all of this stuff that connects to Redis and put it in there. And then when we're done, we should, this one never finishes because it's in a loop. So we should close up nicely with Redis when we're done here, because this is a script that we're just going to run like as a cron job or something. And so what we need to do now is work out the millisecond timestamp from an hour ago and call xtrim. And what xtrim outputs, let me get this right, I think is the number of things that were trimmed. Let's see. There you go. Yeah, integer reply, the number of entries deleted from the stream. So we'll aim for something like that. So I've got, excuse me, I've also got a bit of sore throat from talking at a conference last week. I'm not used to this. So we're going to connect, and we're going to create a timestamp here, and we'll call it like const 1 hour ago would seem to be a good name for that. And that'll need to do something. So for that, we're going to need to get the date and get the timestamp in milliseconds. So JavaScript has something, yeah, that should do it. Date.now that does that. And then we need to work out what an hour in milliseconds is. So that's going to be, there are 60 seconds, 60 minutes, and then like 1,000. That should be the time that was about an hour ago. And what we're going to do then is call xtrim and provide that. So let's say, and that is going to return how many entries were deleted. So entries deleted equals, we have to await it. It's a network trip, xtrim, .xtrim, and then we need a key and a strategy, which is going to be min ID, and then a threshold. So have we got our key? Let's wait for that minute. So we need min ID here, and then we need threshold is going to be 1 hour ago, I think. Yeah, 1 hour ago. And it would be good if I put the quotes in the right place. So we just need a key now. Do I have that up here somewhere? No, but I do have that, which we don't need. Okay. And let's see if we've got the key anywhere in a constant here, or if we just created it. No, we didn't. We just created it. So that's our key that we need. the stream, key prefix incoming. So Pico project incoming. So let's do that. Okay. And then let's do something with this console.log. Okay. That should hopefully delete some entries from the stream when we run it. So let's see how many we've got. We have currently got 351 entries in the stream. So nothing's running here at the minute. So that's going to stay static. So if I then run my code, hopefully, let's switch to the terminal. So let's see what we've got here, trim.js. Hopefully it'll just run the once and trim some, there we go. So 333 things got deleted from the stream. So basically everything that we didn't run in the last hour or run into there, hopefully. And if I refresh this now, you'll see I only have 18 in my stream. And those are the ones from the beginning of this live stream when we plugged the device in. So we're now down to 2 kilobytes of memory used as well. So we save some memory. And that's kind of the point of this. So this would run periodically, this trimming code here. And let's make this a bit nicer. Entries from stream. This will run periodically. And in the architecture we're using, this is probably fine. But you could do other things. So if you want to put the logic in your producer, you can absolutely do that with the exag command. If you're using consumer groups where you want to see that all entries in the stream have been read by some instance of a consumer, you should be able to track that and then figure out what's like the smallest entry ID that everybody's looked at that needs to see it, and then delete it from there. The other way that you can deal with streams is these are just Redis keys at the end of the day. So there's a TTL up here. So if we had a stream that was like just, Pico project incoming, and then the key was like 10/20/2022. So it was today. And we had a sensor that knew to write into that for today, and then we'll split over to 10/23/2022 tomorrow. We could also set a time to live on this whole data structure. So streams are a key. Keys in Redis have time to live. We could set a time to live of like a week or something and keep, a rolling week's worth of date stamped data if we use key names that, are unique to a day so that we know when we're done with this data. So you've got options. We kind of went with the simple one here. I will just put that in the GitHub here. Trim.js. Right, so we stored that away for future use. So that's one of our problems solved, or at least, thought about. We've got a stream now that doesn't overflow. Something is dealing with it. So the other problem we got was if we wanted to search on these things in the future, the very near future, like later in this stream, and we have these values here, we need to stop those being strings and turn them into the right data types. So that should be a simple case of modifying our existing consumer code over here. So what this does at the minute is it writes strings into the body of the JSON document here. And again, it uses JSON path to select the climate object where it's going to put those. And this should be as simple as this is a float. So we should be able to do parse float this, and we won't worry about the case where it doesn't contain that data because we've got control over the system. We know what's coming in. That's also a float. And then the light value, I think, is always an integer type value. So let's go look in the stream. What's the value of L in the stream? Yeah, it's always an integer type value. So we can use parse int, and there we should spell parse float correctly as well. That would be better. Parse int message body.l. So that gives us the hopefully the values now in the format that we want, and the easy way of testing that is going to be to run some stuff through the consumer again and see that this document here then updates so that these values are floats and integers and not strings. So that said, let us try running our consumer for a bit. And there you go, it's reading stuff. You can stop it now. So as you can see, it's reading them back as strings out of the stream because that's how streams work. And then by the time they get into here, they are now in the right JSON data type. So this is good so that when we start to work with this data later, we've got that that fixed. So I'm going to just commit that as well. So commit and push that. So that's up in our repo. And the other thing that I wanted to add to these documents is some sort of like last modified field. So we know when this document was last modified. And again, if we use a timestamp for that, it's a numeric. So we can use numeric ranges in RediSearch later to pick, you know, I want to know about rooms that have had updates in the last 5 minutes where the temperature is between these values, or the light is below this value, or the description contains king size or something like that. So I want to add another field in here for last modified. And again, it's going to be this consumer component here that is setting those, because that's what's creating and managing these documents. So what we can do is basically take the ID that we read out of the string, because that's a timestamp, and then we'll know when those values in the in here, these values that we're putting into the document were actually put into Redis. So there'll be some time lag between them being put in and the consumer getting around to process them. So we'll use that ID value, not the current timestamp. So what we're storing is last modified becomes when the sensor told us what those readings were. So somewhere in here, we've already got we're getting the sensor ID, and we should somewhere be getting the stream ID. Let's see. Here we go. Current ID. So current ID, we're currently using that to remember what ID we've seen, so we can request the next biggest one the next time through the loop. And that's how we move through the stream. What we're also going to do is use part of it, because it's a timestamp dash a sequence number, to create a last modified timestamp. We don't need that sequence number, and things won't understand it as a timestamp. That's just a Redis streams thing, because streams can cope with multiple entries in a millisecond. So we'll just, millisecond precision is fine for this last updated thing that we're going to do. So what I'm going to do then is add a second set on here. So I'm going to do update client.json.set, and I can probably just steal some of this because it's the same key. So we're going to update this document to then have, let's do $.last updated. So this will put an updated field in the root of the JSON document, and the value for that we want is, this is going to get messy, so let's put it down here. The value for that we want is the current ID is a timestamp. That has this minus and then some sequence number on it, so we don't want that. So let's get rid of that with something like that. And excuse me, we also want to store this as an integer, not as a as a string, which is what it currently is. So we need to parse in that. So we need to parse in ID substring. Oh, sorry. We need from the start of the string to the minus. Okay, and then what have we got going on here? We've got JSON.set. And there we go. I think that's right. Okay. So let's try it out. So we're going to set last updated to the current ID minus the thing that's on the end, and we're going to parse in that out. So yes. All right, let's see if it works. So run our consumer again. Something's happening. So it's consuming messages. It didn't crash. Let's see what we've got in room 214 here now. So we've got last updated null at the minute. Okay, so it's sort of writing something, but not the right thing. Let's see why that is. Back to our code. Current ID substring. Oh, I see. Yeah, substring takes 2 indexes. So we want from the start to wherever this minus is, not, I'm thinking it looks for the minus. So we need current ID dot index of, so where is that in the thing? Yeah, I think we need that. Okay, so let's try this again. So off it goes. It's actually processed everything in the stream. So there's a couple of ways we could adjust for that. We could start up the Raspberry Pi and add some more entries. We could do what I'm going to do, which is stop this and refresh this. And you'll see we've got this consumer last ID memo key. So if I just delete that, then it's going to start processing the stream from the start again, which is okay because we're just messing around here. So let's do that. There you go. So now we've got some stuff coming through. And let's see what we've got in our document. Okay, so we now have a last updated with an actual timestamp and not a null value. So that's a good thing. So let's bank that in GitHub as well while we're at it. Push that. Okay. So that's pushed. Right. So yeah, now we've got something that is starting to look more like a document we could maybe do something with. So, it's great gathering all of these things from sensors and stuff. But what I want to do with this project is demonstrate how you could then, work out some sort of conditions that are happening. So, for example, have we got hot rooms that need cooling down, or have we got a room where the sensors failed because we haven't seen an update in a long time? Maybe the battery's flat if it's battery powered, or maybe it's lost its network connection or something like that. And we need to be able to report on those. And that is where we're already using the JSON capability of Redis stack here to store this document. We can add the search capability of Redis stack to do some queries over it. So at the moment, if I'm interested in data in this room, I could do something like JSON.get Pico project :room :214 $. Let's get that last updated. Then I get that value back, or I could say to it, I also want the temperature value. or I could get the entire document and I can update things and so on. So JSON commands are great for this, but we're working in one document. If we've got a whole collection of documents here, so we've got multiple rooms and each room has a schema that looks like this, then we might want to write queries that say, tell me which rooms do have these properties. And that's not something that a key value data store is necessarily normally going to be able to do for you. So that's why we're going to use the search capability of Redis Stack. And what that means is we have to define a search schema. So we have to tell it which bits of the key space we want it to look at and what the data that it is going to index there should look like. And then it's going to maintain an index for us and we can write queries. So what I'm going to do now is I have actually gone ahead and done a lot of the legwork with this off stream already. So inside the repo here, there is a file called create initial data fixtures. I'll just preview that so it looks a bit nicer. What that tells us about, I can actually close this. Let's see. Yes, that's better. So what this tells us about is the things that we need to set up outside of the code in Redis for this code to work properly. So we need to set up that sorted set that maps which sensors are in which room. And we have a command here that does that. That's not a great view for doing this. We have a command here that does that allows us to run the sorted set commands to set it up. And then we have some examples of how you can dereference things. I've also created some JSON documents for a number of rooms. So we have a hotel that has a number of rooms. And what we're going to do is paste these into Redis Insight and create them. And then we'll look at a search index. And I'm realizing that clicking this is not a very good experience. So what I'm going to do is instead of using that, I am going to swap to the GitHub repo and it'll copy and paste a lot easier from there, I think. So here's the same file in the GitHub repo. So we have, as I said, the sorted set up commands. We have JSON for each room. So let's take that and copy it. I'm going to copy it into Redis Insight here. And I'm going to use the workbench here. And as you can see, I've got some previous commands. Let's just clean all of these out where I've been playing with this before. And I don't need the CLI up, so we have more space. What I'm going to do here is paste in a load of commands there. And I can hit play and you'll see it goes away and executes them all. So I've got a lot of OKs. So now when I go back to look at my key space, hopefully we've got a lot more rooms. The other cool thing with Insight here is I'm using a sort of flat view of the key space. I can move it to a tree view and it then looks at my key structures and I can say what the delimiter is and it's colon by default, which is what I'm using. And now we have this sort of tree view of I can just look at the room keys a lot more easily than if I was in the other view where everything's displayed. You can filter the other view as well, but this is kind of like a sort of good drill down way. So it's made as wide as possible. So here we have the rooms. They have the same sort of things as before. They have arbitrary last updated dates. 214 here doesn't have a last updated date because that's the one that our actual sensor's connected to. So we'll run some data into that in a moment. But they all look like this structure. So let us then figure out what we're going to do with them. So we've got multiple documents here. We want to be able to search them and ask it questions like find me all the rooms with a given humidity range or a given temperature range or the most humid room, for example. So to do that, we need what's called a search index. So I'm going to go back to the workbench here. I'm going to go back to my document here. So the way that this works is we're going to create a Redis search index inside Redis here. And that takes a schema and it's going to describe how we want the document indexed. And I'm going to be able to write queries against it. So I'm going to copy this long command in, and then we'll take a quick look at what it actually means, assuming it works. So that says, okay, it seems to have worked. So So let's just paste this command back in here again. So what we're doing here is we're saying I'm creating an index that we're going to refer to as IDX rooms. So I like to call my indexes IDX something, so I know what they are. This doesn't appear in the key space, but you do need it when you're doing other operations on it. So searching or maintaining the index. We tell it what I want to create it. So I want to create an index that looks at JSON type documents whose key prefix is Pico project : room : so just that part of the key space. And the next section is a schema here. So this describes the fields that I want indexing and how I want them indexed. So I'm using JSON paths. So here, $.room, I'm using, I want to call that room in the index. So $.room as room. I want it to be a numeric field that's sortable. And that's true of a lot of the fields in this schema because most things in here are numbers. But we also have this description field. So $.description, I want it indexed as something called description. And I'm saying text for that. So that means full text search capability. So to do a full text search over that. And then as you can see, for things that are in sort of nested objects, we just provide the JSON path. So for light, it's $.climate.light. So hopefully that's worked for us, and we can go to the CLI here and we can look at some documents. But down here in the CLI, we can then hopefully do ft.info on IDX. IDX rooms. Yeah. So this will tell us a few things about the index that Redis has gone away and made for us. It includes our index definition. And it should tell us down here somewhere, yep. This has worked because it's indexed 18 documents. So if it had failed, if we got some sort of mismatch between the index and the data, we would not have indexed any. And it's going to automatically track this for us now. So as our sensor updates values in these JSON documents, or as our consumer does, our sensor puts data in the stream, our consumer reads them out of the stream, updates the JSON documents. Then our consumer doesn't have to have any new logic in it to cope with this. Oh, everything's now indexed. You need to update the indexes. Redis is doing that for us automatically. So it's gone away and indexed all of these rooms. And if I then ask it some questions now. So I'm terrible at remembering the RediSearch syntax. So we are going to use the example in the repo here, and we're going to write some queries. So we've got a query here that says, let's find everything in the index where the temperature field is between 20 and 23. So we're doing Celsius here. And then we tell it what we want back from the matching documents. So I say I want to return 2 items. I want the room ID and the temperature, and I want them sorted by temperature descending. So I want like the hottest room first. So if I go over here and do this, then you'll see I get some data back. And what do we got here is seems like at the minute, 226 is the hottest room, and 225 follows it. And we're just getting the information that we asked for. We're not getting the full JSON document back. I could have asked for that, but you know, in order to keep network latency to a minimum between Redis and my application, and if I know I only need those data items, then I might as well just ask for the ones that I need. So hopefully we can do a little bit of a live update on that, because it should be warmer than that in the office here right now. So if I go over to the stream here and turn on the auto refresh, and then I connect up this little device here, which when it boots will immediately start putting data in the stream, what we should hopefully see is that new data arrives. There we go. Okay, so we're getting new data. It's quite warm in here. I'll turn it off again now. And then if I run my consumer and have it read from the stream and update the JSON documents, it should start seeing some of those new values, and those should get automatically indexed, and then hopefully our query result changes. So if I run the consumer, which I should probably rename from index.js to consumer.js, I'll do that off stream. We've now got values in the 25s. I think it's caught up with everything now because, there we go, it stopped. So it doesn't know anything about the indexing. If we run this query again, then look at the values. I would have expected 214 to be, let's see if 214 has been updated. But I would have expected 214 to be slightly higher than that. Well, that's interesting. Something's happened there that I'll need to look at, but we've got our search query working. It is returning data. That's not quite what I expected, though. Okay, so I'll look at that off stream. But yeah, we have values that got updated in here, and those are being indexed. So we would expect things to have moved along. Right, so I will look at that off stream. It might be that I've cached it or something. I'm going to look at the other example query in my data set. So the other query that I wrote as an example is let's find the room with the highest humidity level and return humidity and description. So here we can do ft.search, index rooms. Star basically says I just want to search for everything. And I want to sort the results by humidity, descending, and basically return just one thing. So limit 0.1 returns only the highest matching thing. And of that thing, I want to return 3 items: a room, a humidity, and a description. I could also return, so we're returning things that I chose to index: room, humidity, and description. I could also return an arbitrary JSON path into the document. So something that isn't indexed as well, even though we use the query to determine which documents match, but we're then not limited to returning data that's indexed. I can return any indexed, or any data that's in the document, sorry. So let's try this. And we do this, we'll see that 18 is the most humid room. So let's see if we try that for temperature, perhaps. And 214 is the hottest room, which you would expect. So what was happening with my previous query? Something was happening in the previous query, but I would have expected 214 to come back as the hottest room there. Let's just take a quick look at that. Oh, that's what was happening with my previous query. So I got a temperature range on there, and 214 is so hot that it's outside of this range. So it was rightly excluded from the query. So if we ran this query, I was wondering, oh, why does 214 not come back? And it's because 214 is 25.1. So when you run this, which says everything between 20 and 23, you would not expect to get 214 at the top of the list, and you don't. But if we adjust this to be like 21, 26, then there it is. So 214 is the hottest room, slightly beating out 217, there, who's got a temperature of 25. So that was my bad. The query's working exactly as designed. It's just I was filtering by a numeric range. So you can sort of see how we can filter by all sorts of numerics here. And we should also be able to, did I put an example query in for this? I don't think I did. So we should also be able to filter for things using that description field. So if I do ft.search idx rooms, and then I do, I think it's something like, this gets everything about that talks about a king. So, you know, things that have a king size bed in them. So we can then combine that with other things. So we can basically say, and temperature is 21 to 27. Oops. There we go. So now we've got everything that has a king room and where the temperature is 21 to 27. And you'll notice I didn't specify to return anything specific this time. So what we get is the entire document back. So it returns $, which is the JSON path for root. So this has now given us quite a powerful search and indexing solution over all of these documents that we're creating and updating from our little sensors. What I want to do in the next and almost certainly final stream for this particular project is take another one of these Raspberry Pi Pico Ws. So we've got one sitting around back here already. There it is. And it's got an LCD display on it. And it's got a little, this is a terrible way of viewing this, but it's got a little motor on it. And the motor is actually a fan, and the LCD display just shows data. So what we're going to attempt to do in the next episode of this series is build something with these sensors here that is fed information from Redis periodically and says, hey, the room's too hot, turn the fan on, and display the temperature in the room to the person in the room. So yeah, that's what I'm hoping to go with this. So that will be next week. I'm streaming a week from today, so please do come back and join me then. And yeah, what we've got to just to wrap up is some stuff that you can go check out. So obviously go check out the repo for this. I put that in the comments and you can see that there. So I will tidy this up a little bit more after this stream, and I shall probably rename that index.js to be consumer.js. It's getting confusing. Now we have some other things in there. We also have Redis live schedule, which is our team's schedule for when we're streaming. So you can see on this, I'm actually back later on today with office hours. Those are actually held in a different place. Those are held over on our Discord server. So you should join Discord if you want to do that. And then tomorrow, I'm back with several members of the team for a show where we look at things that were asked on Discord every week and try and answer your questions, or just show interesting things that happened on our Discord that we want to share with the community. So if you want to go ahead and join our Discord, the URL for it is down the bottom. It looks like this. It's a pretty friendly place where you can talk to us, the Redis staff and DevRel team, as well as the rest of the community. And we periodically run some programs through there. So right now we are running something to do with Hacktoberfest. So Hacktoberfest is, let me find that. It's on redis.io/community. There we go. So Hacktoberfest is a monthly or an annual thing in October where we work with other companies. It's mostly organized by DigitalOcean, and make issues available in open source repos so that people can get interested in some of our stuff, make contributions to those. And DigitalOcean tracks these because they get a special label. And if you do 4 in the month, then DigitalOcean may issue you with some sort of swag. We're not responsible for that here at Redis, and we're not the only place offering issues for Hacktoberfest, but we wanted to take part in it. So we have a page here that you can go to. It's on redis.io. And here it is. And if you scroll down, it shows you exactly how you can be successful with working with one of our issues. And there's also a link to find all of our open issues. So if you click here, we have set up a GitHub search. So we currently have 9 that are available. If you don't like any of these, keep checking back. We're adding more. And what do you need to be successful with these? Well, they're not core Redis product issues. So largely the sort of demos that you see the developer relations team build here on stream, or things that we do in our Redis University courses, they generate a lot of repos in a lot of languages. And we also have a lot of Redis clients that need example scripts. So we've been doing a series of write example scripts for Node Redis, for example. And we have a template for that, and we can help you be successful. So you don't need to be a C developer to do this. There's a lot of stuff out there in Python, Node, Java. There's also some stuff that is more CSS or front-end oriented, because we in the team are generally database back-end type developers, but we have to build demos that involve front ends sometimes. Those aren't necessarily the nicest looking front ends. And if you'd like to help us out with those and get a Hacktoberfest contribution, we would love to see you. So yeah, that's it for today. That's what I've got. And thanks for coming along. I was, as I say, out at a conference last week. I was really, really pleased to meet some folks out in the real world who were also using Redis streams with IoT. So if you have anything interesting to talk to us about, especially with IoT, I'd love to hear about that. Go to the Discord. We have a channel for Internet of Things. I post stuff about these streams in there, and I'd love to hear about your projects and see how you're getting on. But yeah, other than that, that's everything for today. So I will be back later today on Discord with the Redis University office hours with my colleagues, and I will be back tomorrow on the This Week in Discord show. Thanks very much, everybody. See you next time.